good morning, happy Friday, kind of, and welcome to today's session on cutting edge IoT, industry problems and practical solutions. Industrial IoT has been a major focus for manufacturing in recent years, promising greater visibility, reduced downtime, and smarter operations. But in practice, many IoT projects struggle to move beyond the pilot stage. And that's often not because of the technology itself, but because the practical engineering challenges around sensor integration, connectivity, power management, and security. Today's session is about addressing those challenges head on. We'll be focusing on real design decisions that determine whether an IoT system delivers measurable value or becomes another stalled initiative. And we'll be sharing insights from real deployments, including examples where applied IoT engineering has delivered improvements such as reduced energy consumption and faster, more reliable connectivity. We're joined today by two members of IMR's electronics team. First, we will have Mike Hibet, Senior IoT Technologist at IMR. Mike brings over 40 years of experience in embedded systems with a particular focus on firmware, electronics design, and device security. He has led product development teams in organizations such as Intel, Philips, and Thales, including leading high-grade cryptographic software development. Alongside his work at IMR, Mike also lectures in embedded systems, bringing both deep technical expertise and strong practical perspective to today's session. We're also joined by Shane Thompson, Senior IoT Researcher at IMR. Shane is an embedded systems engineer specializing in firmware, hardware design, and cloud-connected IoT systems. His experience spans LTE-enabled sensor devices, predictive maintenance systems, and industrial control applications. His work focuses on building complete end-to-end IoT solutions from device-level design through to data visualization and system integration. Together, they will walk through the practical realities of designing and deploying industrial IoT systems that are secure, reliable, and scalable. If you have any questions throughout the session for either Mike or Shane, please use the Q&A function that you can find on the bottom of your screen, and we'll get to them at the end. And so, without further ado, I will hand you over to Mike to get us started. Welcome, Mike.
Thank you, Gary. And good morning, everybody. And nice to see so many people that I do know already in the chat. You're very welcome again. Look forward to speaking to you. Before we get in, I'd just like to talk a little bit about IMR for those people who are maybe not familiar with us. So IMR, we're a technology research centre recognised by Enterprise Ireland. We were established in 2014 with the goal to assist industries based in Ireland. So that's any Irish company or any company resident in Ireland. We have essentially four thematic pillars or areas of research: digitization, which is the group that I'm in; robotics and automation, which focus on helping industries improve their use or introduce robotics and automation systems into their production facilities; design for manufacture. This group cover both traditional subtractive manufacturing, such as precision engineering, CNC machining, that kind of thing, as well as additive manufacturing, 3D printing in production environments. And finally, our largest thematic pillar is sustainable manufacturing. We lead the Circulaire initiative for the Irish government, among many other activities, specifically focusing on CO2 reduction. So we're part of the national and European Union drive to reduce CO2 emissions. So IMR, we have two facilities, one in Rathcoole in Dublin, and this facility, a 35,000 square foot industrial production testbed, as we call it, which is where all of our engineering resources are based. And that's where myself and my team are based. So within the digitization group, we split into a number of different teams. My team, the electronics group, there's 5 of us. So you're going to hear from myself and Shane today, but we also have Degirdas. Degirdas is actually one of the longest serving members of IMR. He joined when I think there were only about 5 or 6 people. We're now over 140 research engineers, and we're scaling up starting this year. Martin Murphy is also an established embedded engineer, having worked for a number of industrial controls companies as a designer, and Marcio, who's our most recent hire, also has a track record within embedded systems development. So that's just a brief overview. I'd like to now move or hand over to Shane to start the presentation itself. Thank you.
Thank you very much, Mike. And thank you, Gary. Welcome, everybody. Before I get cracking on the content, I'll give an overview of what we'll be talking about today. Our first topic will be centered around the reliability that sensors can add to a system. After that will be remote monitoring using cellular communication, particularly battery-operated remote monitoring. And following that, Mike will present some further case studies from his experience. So without further ado, I'll get into our first topic, sensor-driven reliability. Some processes just simply cannot be manually checked as often as necessary. This is generally either because of an inherent complexity of the process, the time it takes to perform the checks, or it can simply just be too expensive. No shock to anyone here. That's where sensors come in. I'm sure, as you know, for nearly any physical phenomenon, there's a sensor somewhere to measure it. So with the sheer number of sensors to choose from, how do you go about selecting the right one for the project? Well, the question you have to ask yourself before getting anywhere near implementation is, what are the simplest data points that tell me the most about my system? And answering this question will be the first step in setting yourself up for success in your electronics projects. Now I'll talk about a project with a simple data point, but interesting problems. Last year, we worked with a company that taps threads for nuts. So they make nuts and bolts, and they manufacture these nuts by the mountain, just thousands and thousands of parts every single day. And the tapping tools, as you can see in the graphic, will of course get worn down through all this use. But the company had no good way of gauging the wear on their tapping bits, as different processes and different materials wore the taps different amounts. And that uncertainty led to breakages, and those breakages, of course, led to costs. Each time the tap broke, parts created with that tap would have to be scrapped. But not only that, all the parts that were created with that tap that day would also have to be scrapped. So the hundreds or thousands of these parts every time there was a tap broke. So, easy enough to say that is not very sustainable. They worked with 3 options before coming to us. All had their drawbacks and compromises. The first thing they tried to do was have someone manually check the taps for signs of damage. This was, of course, highly manual, which leads to high labor costs. It also proved impossible to check every tap often enough just from the sheer amount of processes. And because of this, many taps were breaking and a lot of material was wasted. So next, they tried to just use a realistic calculation of how long they should run their taps. This led to a reduction in tap breakages, but not zero, and they were still losing material. And it proved too expensive for the processes on how many nuts they were losing. So the third option was to go very conservative, and it saw them throwing out taps at the end of every single day. This was seen as the only safe way of ensuring there was no material wasted. But of course, to get this 0% break rate, they had to waste so many tools. And it was not only a nightmare for the likes of our sustainability team, but a nightmare for their company's finance team too. So they came to us. And we worked about bringing on a fourth option. We added a sensor to their tapping system for real-time monitoring of the wear of their actual taps. They require real data to make real estimates about the condition of their tools and processes. So this system is the way to pave forward to implement predictive maintenance. So of course, we asked the question, what's the simplest data point that tells us the most about this system? And the answer was strain. As the taps were used and they were worn down, their sharp edges becoming blunt, more force was needed to cut the grooves. And this force could be measured in the torsion on the material. So a simple strain gauge can tell us that. And strain sensing has been done before, but the challenge in this project was integrating a strain sensor into the client's existing tooling. That meant it had to be wireless, it had to be battery operated, and it had to fit between this 15 by 45 millimeter tool. There's simply no off-the-shelf solution that comes close to these specifications. So we created a sensor that fits their needs. It sends data to a receiver over Bluetooth Low Energy. It runs off batteries housed within the tool holder, and the whole thing fits in their machine, tiny PCB to perfectly fit their process. So previously, where the processes were operated without visibility and tools were discarded every day as conditions were unknown, this system enabled a shift to control. Now tool condition is measured and decisions are data-driven, leading to sustainable and cost-effective operation. So with just one data point and the printed circuit board built around it, they were able to finally see the data from their process. So rather than having someone crack open the machine a couple of times a day and just try and look at the tool, or rather than just assume, okay, it could be broken, we'll throw it out. With this system, they're actually able to see every day and every tap what is the wear on their tools. So now I'll move on to the second topic for today. I'll speak about remote monitoring and how to alleviate the headaches it causes, and I'll give a case study from our portfolio. Some of you may be unfamiliar with remote monitoring. It involves deploying hardware, so generally sensors and actuators, to hard-to-reach areas to make it easier to monitor and control processes without the need for an operator on site. This gives a number of clear advantages. So first of all, just visibility, allowing you to detect events and monitor assets from some otherwise inaccessible locations. It enables automation, where systems can monitor and respond to conditions without any direct human involvement. This leads directly to cost savings by reducing the need for travel and on-site intervention. It provides great value in better response time to crises too. And finally, it expands market reach by enabling solutions to be deployed in environments that would previously have been out of scope for projects. But in practice, it's not all that simple. Designing these systems introduces real challenges. There's the complexity of building for low-power cellular operation. Battery life and battery monitoring become very critical, because if your battery dies while it's out in the field, your system is gone. And the connectivity itself can be fragmented, depending on location and network availability. Latency can be unpredictable, making consistent communication difficult. And finally, there's still some maintenance, with battery servicing and updates all add to overhead, which in turn adds cost. So while the value is clear, delivering it reliably is where the real challenge lies. To meet these challenges, systems have to be designed deliberately and as a whole solution. At the hardware level, the focus is on efficiency from the ground up and avoiding unnecessary components and processes. It is also crucial that the system can operate autonomously without the need for on-site intervention. Communication then becomes the main cost driver. It has to be carefully controlled, reducing how long and how often the system transmits. This not only improves battery life, but will help manage the latency for critical communication. Finally, at the firmware level, the goal is to maximize time spent in low power states. This extends the battery life, which helps in minimizing the need for maintenance intervention. And it's a combination of all these principles that allow reliable, long-term remote monitoring. The next case study I will talk about is a project where two companies came together and we created one solution to address their remote monitoring needs. That need was an efficient communication system to deliver remote monitoring with as little operator overhead as possible. So both companies wanted to reduce operator time and associated costs. So the requirement was simple to state, but difficult to achieve. They needed a device that could be deployed easily, run on battery, and operate for years without any intervention. Off-the-shelf solutions were tried before, and the company reached out to us because they proved ineffective. So the core challenge here is power. Cellular communications is extremely power hungry, using far more energy than the sensors or the data processing on board. That means all decisions had to be made to reduce the power burden from this communication system. To do that, we had to tightly integrate the hardware and the firmware. Once we understood that communication was the dominant energy cost, the system had to be designed around reducing that overhead. So data was batched and transmitted intermittently. This allowed us to fully power down the modem between transmissions instead of maintaining a connection. This was a big saver in the power burden of the project. The system was designed to wake up only when necessary, carry out its tasks, and then return to deep sleep as quickly as possible. So across the hardware, firmware, and the way the data itself was handled, everything was built to minimize this active time and maximize time spent in sleep. With these measures, we were able to get a 17% reduction in battery usage compared to the reference hardware at the start of the project. Another key factor for us was simplifying both deployment and day-to-day operation of this system. So for setup, we use a phone-based provisioning flow. Devices are connected and configured directly over Bluetooth with no specialist tools required at all. That allows for fast in-field installation, and once deployed, the system becomes fully autonomous. Devices transmit data to the cloud where it's immediately available to the app, and that same app can be used to reconfigure devices remotely when needed. This removes the need for manual checks and significantly reduced operational overhead. So what was delivered was a system that could operate reliably over long periods without intervention. Through the design approach we've discussed, we were able to significantly reduce energy consumption, extend battery life, and reduce operator overhead through deployment and through the whole device use. The estimated battery life is measured in years and not months. That directly reduces the need for maintenance and site visits from operators. And of course, the magic words, this all works to lower cost for these companies. At the same time, the platform provides real-time visibility and control, improving how these systems can be monitored and managed. So the last point I'll leave you with before I hand back to Mike is this. Generic solutions do not solve specialist applications and their problems. To achieve the level of efficiency and usability we've shown, systems have to be designed congruently as a whole. That means bringing together hardware, firmware, and software into a single integrated solution. And with that, I will hand back over to Mike.
Thank you, Shane. And I'd also just like to say congratulations, Shane, on your first webinar for IMR. Very interesting. I would, before I go on with my section, I would just like to add a point to the Talos project that Shane was discussing there. That not only did we design the electronics, we also developed the mobile phone application itself. That's another capability that we have across several teams in IMR, and we've done this a number of times for different clients. Whenever you're providing a piece of equipment with communications capabilities, the problem's not solved until what collects that information brings it back to users with actionable insights. And indeed, another part of the digitization group works in the area of data analytics and AI, so that we can support clients with doing deep analysis of their data, including in real time, to enable them to gain those additional insights. So I'd just like to talk about, I have two cases that I specifically want to talk about, which are from personal experience. The first one is to do with the monitoring of gensets, diesel-powered electricity generators, which are used at, in remote field applications. There are a large number of manufacturers of this type of equipment, and their business model is based around not selling directly to end users, but selling to distributors or rental companies who will put their equipment out onto a variety of sites. And this is a fairly typical kind of installation. On the right here, we've got a generator at a construction site, obviously somewhere nowhere near connected mains power. And on the left, possibly an environment which many people are familiar with, which is festivals. And of course, particularly in festivals, power is very important. And this is where we get to the crux of the manufacturer's problem. And that is, gensets are complicated devices and potentially very dangerous. So when these go to a remote site, particularly for things like festivals and other outdoor events, only the supplier is permitted to operate or maintain these generators. So not even putting fuel inside them. That has to be done by the supplier. And indeed, when these generators are rented out, the expectation by the end user is that contractually that generator is going to work continuously for that outdoor event. And this project that I'm about to mention actually launched, it's probably about 6 years ago now. So this particular manufacturer that I met with exposed the problem that they had. One instance in particular where a distributor had leased the generator, a generator to an outdoor event, and it ran out of fuel, and it ran out of fuel because somebody had miscalculated exactly how much fuel would be necessary for the duration of the event. Not as bad as an aircraft running out of fuel, but legally there were problems, and fees were involved. So they were very sensitive to the fact that the only way that they could guarantee that this device was working was to have somebody physically on site for the duration of the event, which could be done, but of course is very expensive. So they came to us and asked, is there any way of being able to have an addition to this generator that can provide feedback of the status, temperatures, speeds, and of course fuel levels? And that's what led to this following product. So this is a product that I led the hardware design of. It's a DIN rail mounted device, so it could actually be placed inside of the generator. And it had a small microcontroller internally and a cellular modem to enable the transmission of data via the LTE cellular networks. The connections, the green things on the front, are actually multiple types of interfaces to support different generator manufacturers' equipment interfaces. And this device is very popular, not only from the fact that it could now give warnings of imminent issues such as over temperature or low fuel, but also allows the rental company or the distributor or even the manufacturer themselves to be able to see where their devices are deployed, where they are actually located physically, and to be able to analyze the data coming back from this device, not only to provide continuous operation or assurance of continuous operation, but also to give insights into predictive and preventative maintenance. So I'd now like to move on to another use case, which is somewhat more recent, which is different and yet very, very similar. So this is the actual internals of a device that we've designed for a particular client. This client works in the field of heavy plant lubrication, and so items like JCBs or large CNC machines. And the device that they provide at the moment, as with any other manufacturers in this area, used a very simple push button display type controller, very similar to the immersion heaters that we have indoors. And they wanted to bring this product, they wanted to refresh it and bring it more into the 21st century and provide remote monitoring of these devices. A similar kind of model to the previous genset example, but here we were getting much more involved, and this board would actually be integrated into their product as opposed to being an optional item. It consists of a small microcontroller with Bluetooth and Wi-Fi connectivity, and we designed a separate cellular printed circuit board. This provides very low power, very long range cellular connectivity using NB-IoT and Cat-M1 LTE, communication protocols, and it uses a SIM card just like any other mobile phone type device. And this was designed to be optional. It would normally fit here on the board to enable the company to provide, various price options and SKUs for different applications. So if this device were fitted inside, for example, a factory, then Wi-Fi would be used. If it's on a JCB out on a construction site, then the cellular connectivity would be provided. One of the key benefits for them with this device was around being able to assure that lubrication is being done on these machines which are being leased out to, for example, construction sites. So remotely, they're able to tell what's going on. But also with the Bluetooth interface, a mobile app can be used for somebody to be able to walk around a facility and examine the status of their lubrication systems, or for a maintenance engineer to be able to, operate the controls in a more 21st century manner with an app on a mobile phone. Now, the use of an app on a mobile phone is really significant because, and this happens a lot. I see this a lot, that when a company comes to us with a particular problem or even a particular set of product requirements, once you've implemented those and you're receiving data and you're you're gaining insights in the area that you're interested in, you suddenly discover that that data can be useful, or the tools that you're using can be useful for other kind of market channels that you hadn't even thought of when the project was first proposed. And certainly with this one here, what we were able to do is to advise the client that if your end user is using your application to control a machine, the manufacturer is able to detect, for example, this machine has been running for 20,000 hours. It's due an air filter change, and they can post to that application a very specific, targeted, and useful advert saying your genset is due an air filter change. We're doing a special offer on air filters at the moment. And this became incredibly powerful for the manufacturer because previously they had no contact with the end user. In some cases, they didn't even know who they were because the products were sold through a distributor or leased out through a rental company, just like in the first example. But now they have not only a direct connection to the health of the products that they manufacture, they essentially own the eyeballs of the end users themselves. Now, this insight was very useful, but truth be told, that application of the mobile phone application actually came out in that first use case 6 years earlier. So even though they're in a different, completely different business or industry, the same kind of capabilities were able to deliver a similar benefit, a benefit that was not expected when the project started. Before we go on, I would like to just talk about a training course that is coming up. This webinar today is obviously very short, but we do have a training course, Beyond the Hype, Deploying IIoT for Smarter Businesses, which goes into much more detail. It's a day-long training course. The next run of it, we do this several times a year. The next run of it is 28th of May this year. And we're delighted to say that this training course is being supported by Engineering Skill Set. And Gary will give you the opportunity to leave a message should you be interested in more details or how to register. So thank you very much. And with that, I'll hand back to Gary.
Great stuff, Mike. We had said in a social media post that when Mike speaks about electronics, people tend to listen, and that's why. And good stuff, Shane, too. Very smooth for your first webinar. I'll bring you both back in now as we get to our Q&A. We have a couple of questions coming in, and for everyone all of the attendees, if you have any more questions, just drop them into the Q&A function. So let's see. Oh yes, I have a quick poll that I'd like to launch before that. But Mike, I just wanted to ask you a little bit more about that course. So who in an organization should be taking this kind of a course? Who does it make most sense for? And what would they come away with, and what would they be able to bring back to their organization after taking the course?
Yeah, thanks. That's a very good question, and I really should have spoken about that more when I was talking about the training course. So that course, I deliver that course. I designed it really with primarily um, engineering managers and productions, like senior production engineers, or really even just production engineers, who would like to understand the technologies and so the technologies that are available to help them sensorize their manufacturing processes, and also a deep dive into the actual communication protocols that are available. And in both the cases of sensors and communications, going into the benefits and the pitfalls to enable you to kind of pick and choose an appropriate sensor communication technology for your particular problem. As Shane mentioned earlier, there are no generic solutions. Every problem is specialized, and you really do need to have some background. I also go into the human dynamics of developing an IoT solution, which are as important as the underlying technologies. So we talk about how do you go from a proof of concept to scale. So, you've got perhaps one enthusiastic production engineer who comes up with a system and he runs it on a hobbyist development platform with hobbyist sensors, and he or she can demonstrate, that this works. That's great, but then how do you scale it to 100 sensors, or maybe 100 sensors times 10 for 10 different factories, and who's going to support it in those other factories? And also, how do you communicate the value proposition to your senior management, the executive, to gain funding for that expansion and all that kind of thing? And then also the final module covers device security. It's an area that I'm very experienced in, I'm very passionate about, and that subject alone, I could probably spend a complete day talking about it, but we managed to get it in with the other subjects in a single day. And then coming back to your original question about who, I would also say that this would be useful. It's only a day, it's virtual, so it would be useful for perhaps senior engineering managers who know nothing about IoT and would like to be able to understand what their engineers are talking about. So that's it. Thanks.
Excellent stuff, Mike. Thank you for that. Okay, so we've got lots of questions in. Oh, the first question is for you, Mike, and it asks, what other types of electronics development does your team get involved in?
That's that's a good question, and again, I would say that's something I should actually have mentioned when I was introducing our group. Um, Very varied, actually. So we've spoken a lot about industry, like manufacturing companies, but because we are a research center, we can deliver research work for clients based on national and European grant funding. So companies, any company with a CRO registered in Ireland can avail of de minimis, which is a maximum of €300,000 over a rolling 4-year period, provided freely by the government, and some of those grant offerings includes up to €30,000 with no financial contribution required from the client. So we get to work with a lot of relatively small startups, very small startups in some cases, maybe 3 or 4 person organizations, and even medium-sized SMEs who are looking to do a fairly large project, but would like government support for some of the funding. And we can do projects up to over €500,000 through the duration of a couple of years. And in some cases, the government will fund up to 80% of the costs of that. So that makes us very accessible to a large number of companies. But more specifically, getting back to your point, we work with a lot of medical device and pharmaceutical companies, looking at actually product development, not just process enhancements. So I can't give specifics because projects which are not yet in the marketplace are obviously company confidential. But also one I can mention is a hotel door lock servicing company based in Burton Port in Ireland, and their business is upgrading hotel door locks from magnetic card to plastic RFID cards, and there's still plenty of hotels out there that need upgrading. And the normal upgrade path from any lock service company is to remove all of the metalwork of the door handle, all of the electronics, and replace it with new electronics and new metalwork, so new brass work. That traditionally has been a very expensive process. There's a lot of brass being discarded, for example, and further work on the door. What this one company, very small, 3-person company, realized was that if they could have a very small printed circuit board that went along with their electronics that they wanted to fit, that combination of electronics could fit in clients' existing door lock hardware. And as you can imagine, that significantly reduced the cost to the hotel, and also meant that the look and feel of their hotel, wasn't suddenly changed. When I started with that client, actually back in 2018, before I was with IMR, they were supporting 4 companies. Today, they're now a client of IMR. They are up to 140 hotels based in Ireland, the UK, and South America, and that's all through as a result of the development work that we did and the printed circuit board that we designed and manufactured for them, until we got to a point where we could then hand that design over to an Ireland-based PCB assembly company.
Excellent. Thank you, Mike. Shane, I think this one could be for you. Is it an advantage to use multiple sensors in one electronics design?
That's a good question. It depends on the design. It depends on what you actually need to get out of your system. Just tacking on more sensors because maybe you have the budget or you have the power to do it is not good enough. But if what you're trying to measure, if the process you have, if you're going to get more insight from it, then absolutely. Like some processes, if you're doing like motor control, you'll often need 3-4 sensors, really, like your voltage and your current and your RPM will all have to be measured. But if you're just measuring, let's say, if all you want to know is how fast something's going, then maybe you don't need all that. So you want to keep as little as you can get away with, but if there's more insight that you can get out of it, then more sensors can definitely help.
Very good. And when starting a new electronics project, where should the first focus be?
I suppose that will depend for all projects on, the exact area, but in general, it has to start with the constraints. What is the environment that you're actually working in? Things like from earlier, if you have access to mains power or not, is going to vastly change how you can design your electronics and how you can design your communication systems, and physically where in an environment you'll be deployed. For example, if you're within a couple of feet of what you're transmitting to, then Bluetooth is an easy sell. Whereas if you're, in a very dense forest in the middle of nowhere, that might have to be, a terrestrial NB-IoT or satellite communication. So it really has to come down to speccing your problem before you can start solving it.
Very good. Okay, question here from Donny. Can you give assistance with designing custom hardware? So do IMR give assistance with designing custom hardware? Yep, go ahead, Mike.
Yes.
Simple answer. Yes, we do, Donny. Get in touch. Get in touch to discuss more. Okay,
balancing out my answers compared to the lengthy previous one.
All good. A question from Daniel. At TU Dublin, we have a laboratory for teaching condition-based monitoring on rotating equipment based on your experience. What are the most critical competencies you still see missing when training engineers in this area?
Now that's actually, and I'd missed it. So it's TU Dublin. Nice to see you on the call. That's very interesting because it's one of the offerings that we provide is that we have put a very high power motor, three-phase motor. It's a 1.5 kilowatt motor with a controllable braking disc on it into a cell with controllers and remote connectivity for a very large controls manufacturing company. And we host that so that their engineers who are actually based in India can run their applications and their tests on real hardware without it being physically with them. And as your TU Dublin probably very aware, there's quite a lot of safety issues around having heavy duty rotating devices. And so health and safety and electrical engineering certification is very important. So you can't just get a bunch of electronics engineers like myself to go and set up this kind of equipment. You actually need a certified electrician. And in our experience, you can't even ask a certified electrician to sign off on a small piece of work that you've done. They have to have done it themselves. So that can be quite challenging. And in terms of training, I think I'd probably have to think about that one a little bit more. So perhaps if you can reach out, give us your name and email address, and we can just chat about it. And it would be lovely to chat about it anyway, and even to see your setup in your lab, and perhaps you to visit us in Mullingar and see ours.
Very good. Okay, so there's two recommendation type questions here. One is asking, what does the team consider the best wireless communication technology to use in an industrial setting? And the other is asking, which cloud platform would you recommend for storing and managing data collected from IIoT devices?
Right, let me see about Oh, right. Yeah, I'd almost forgotten the first one. Simple answer to the wireless communication question is there is no specific technology that's best. Um, each technology that we can discuss has its benefits and downfalls, or indeed even there are use cases where a particular wireless communication is demanded, and there are use cases where a different communication technology is demanded. Across the set, and I actually get asked this question when people visit us in Mullingar. You know, they say, like, in this facility, this is a manufacturing test bed. You know, what wireless communication protocol do you use? And the answer is we use Wi-Fi, of course, because it's convenient. People can use it on their mobile phones and their laptops. They don't need special adapters. We use Bluetooth Low Energy for battery powered, extremely long battery life sensors. And we also use 5G. And 5G is a technology similar to Wi-Fi, a lot more expensive, but is extremely resilient, reliable, and secure compared to Wi-Fi. So 5G would be appropriate if you have wireless communications that are safety critical or business critical. And on the training course, I go into that in a single module itself to talk longer about it than that. And what was the second
Uh,
part of that question?
so it was, which cloud platform would you recommend for storing and managing data collected from IIoT devices?
Again, there's no one story fits all. Google and Microsoft have their own platforms. For visualization, personally, I like Grafana. It's free and it's very powerful. And I've seen a number of different companies run their dashboards using Grafana. As an organization, um, certainly within the development teams, we do prefer open standard protocols and platforms, really, so that we're not in a position where we're advising a client down a single vendor route. We are vendor agnostic. And I forgot to mention at the beginning, we are actually a non-profit organization. We're partly funded by Enterprise Ireland, so we kind of act like a government department, but we're a non-profit, and we don't enter into business arrangements with vendors of equipment or platforms or sensors to promote their products.
Excellent. Okay, there is a question for Shane here. In the thread tapping project, the signal that was the single biggest source of information was strain. How did you figure that out?
Good question. That would have started with a workshop with the company. Basically, the company came to us detailing their need of, we have these taps, we're throwing them out every day, and we want to stop doing that. And it came with just talking to them and figuring out their process. And by talking with their engineers, we were able to see that, okay, visually, what would you guys be doing? Like, how would you manually check this? And they were saying how, like, it gets blunt and you can kind of see on the tool itself. And then we thought, okay, blunt. So what physically changes when it gets blunt? And we have our design for manufacturer guys were from the start of this project again. And they said, well, if it's blunter, it will take more force. And if it's more force to cut, that means there's more force on the tool, and that torsion can be read. So it was, I suppose, with any project, it's the same. It was a combination of understanding the client's conditions and processes, and then having our expertise in-house. And it's something I didn't mention, actually. That project in particular, QuickTap, is a nice melding point of a couple of our teams within IMR, where we're handling the electronics and the data side, and there's a whole more mechanical side of things that I actually don't know that much about, that kind of fed into the start of the project and throughout. I hope that
Excellent.
answers your
Okay, so
question.
we have loads more questions, but we are just gone half past, so we will get back to you. So there's James, Donny, Tommy, you all have questions in there. We'll get back to you by email. AJ has one. But for now, I think, guys, thank you so much. That was excellent. Like really, really good. Before we go, I am just going to let you guys know that we have, so for that training course, I think Claudia has actually popped in a link into the chat for it. But we also have a Discover IMR event coming up on the 22nd of April. So if you're from a manufacturing company and you'd like to come into IMR in Mullingar, have a look at our advanced manufacturing pilot factory, all the different areas that we have that Mike touched on at the start. Claudia is going to put the link for that into the chat as well. So click on that and register your interest in that. But for now, guys, again, Shane, Mike, excellent stuff. Thank you very much. And thank you all for joining. Hopefully that's helped you forget about the pain of Ireland's result last night, if you're Irish, of course. If you're Czech, go on celebrating. But for us, yeah, okay, we leave it there. Thanks very much.
Perfect. Thank you very much, guys.
Goodbye all.
Cheers.
Goodbye.